This lesson is on redox reactions. So we've already talked about the four main types of reactions, and redox is another type of reaction. And we're going to see that it kind of fits in with a couple of the ones that we've already mentioned before. So, what is it? Well, redox is actually a shortened way of saying oxidation and reduction. It's just kind of the way the chemists have always referred to this. So it has to do with electrons transferring. And you've got the four types of reactions we've already mentioned, right? You have synthesis, combustion, decomposition, and then you got the single and double replacements. We've already mentioned those. There's another way of classifying them. These oxidation-reduction reactions, or like I just said, we shorten that to redox. And this, by definition, is simply just any reaction in which electrons are transferred from one substance to another. Okay, so you've got electrons transferring. Things are going to change their charge. Okay, so really what's going on here, the charges will change. That's what we're looking for. Charges will change. So for instance, here's an example. This is of burning magnesium. Now you've seen this done before. You've seen magnesium lit, right? It burns very, very brightly. So the reaction that's actually taking place, since it is combusting of a metal, it's got to be reacting with oxygen. Well, you got solid magnesium reacting with oxygen gas. Okay, it's going to give us magnesium oxide. All right. Well, what's important to realize is this reaction, as it's happening, here are our two magnesium atoms, right there. Okay, and here's our two oxygen atoms. What happens in this reaction actually is that two electrons from each magnesium get transferred to each oxygen. So this one's losing two electrons, this one's losing two electrons, this one gains two electrons, this one gains two electrons, and the result of that, okay, right here, is you have a magnesium ion. That's what you're seeing over here on this side, okay, that magnesium ion, the Mg over there. It's actually the ion, and the oxide ion with a -2 charge, okay. Well, it's important to realize what's actually going on here. This is just magnesium metal, solid magnesium metal, elemental magnesium, right? You see it over there? Okay. This has a charge of 0. It has no net charge. Same thing, this oxygen is elemental oxygen, so it's going to have a net charge of 0 on it. Over here, though, when it's in the compound, the overall compound has a net charge of 0, but the magnesium is actually +2 and the oxide is -2. Okay, so the net is 0, but you actually have these ions forming. That's what's formed. Okay, so oxidation. So this is one half of redox reaction. An oxidation reaction is a complete or partial loss of electrons from a reactant. Okay, loss of electrons. Oxidation is loss of electrons. Example of this, let's say you have a sodium atom. You've seen sodium before now. What will happen to sodium in an oxidation reaction if it loses an electron? So we're starting with this reactant, sodium, and what is it going to make product-wise? Well, you get a sodium ion. Okay, it's losing an electron, so off pops an electron. Okay, that's what's on the right-hand side. It's got to be on the product side because you are losing an electron. And when you lose that electron, the sodium becomes an ion. It's no longer just in its elemental form. It's now an ion, a positively charged ion. So note that the overall charge on the right-hand side is 0. You have a positive and a negative, and over here it's 0. They are equal in charge, even though now you have an ion and an electron. Okay, this reaction does not just happen by itself. This happens in conjunction with a reduction reaction. This is what's saying down here. To occur, the electron must be accepted by another reactant. So this has to go somewhere. You're not just going to have electrons flying off and having sodium ions left. This has to go somewhere. It has to be picked up by something. So they happen in conjunction with a reduction reaction. Okay, so a reduction reaction, the opposite of losing electrons would be to gain electrons. So this is a complete or partial gain of electrons by a reactant. Example here is if we take elemental chlorine. We got Cl2. Okay, that's its elemental form. It's got a charge of 0 on it right now. And so it's going to gain electrons. Notice they are on the reactant side this time. The two electrons are on the reactant side. They are going to combine with the element to form a chloride ion. We get two of them because the elemental form of chlorine was Cl2. Okay. So this has to happen in conjunction with reduction reactions, or reduction and oxidation reactions have to happen together. If they don't, okay, nothing is going to occur. The way that there's other ways to learn this, but a common way of remembering which one is which, and I highly suggest learning this, is Leo the lion says grr. I know it sounds kind of grade schoolish as a way of remembering, but what's that telling you? That is losing electrons is oxidation, Leo, and grr, gaining electrons, is reduction. So this is kind of a nice little way of remembering it. If you're not sure about which one's the oxidation or which one's the reduction reaction, you look at what's happening overall. Is something gaining electrons? So this one, the electrons are being gained in the reactant side, okay, and then they are on the products. They've now become part of the elements, right? This would be gaining electrons. It's adding electrons. On the other one, the previous slide, it's losing electrons. An electron is coming off of that sodium. Okay, and then we have something called oxidation numbers or oxidation states. And you've probably seen these on your periodic table. They are usually the numbers, a single number or a number separated by a comma, and they often indicate the kind of charge a substance will have. This is the number assigned to an atom or ion to indicate its degree of oxidation or reduction. So how much is it oxidized? Has it been oxidized or reduced? Plus 1 or minus 1 being the smallest amount, right? An example reaction here, which we'll use for the next slide or so. You've got potassium atoms reacting with chlorine gas to give you potassium chloride as a solid. Well, right here, this potassium atom is neutral. It has a net charge of 0. It's got an oxidation number of 0. This chlorine has an oxidation number of 0. Well, what's happening over here, these are no longer elemental in form. These are now ions. Potassium loses 1 electron and has an oxidation number of +1. And chlorine, each chlorine gains 1 electron and has an oxidation number of -1. So we're going to refer to these, yes, that they are the charge on it, but we're going to refer to them as the oxidation number. When an atom or ion is reduced, the oxidation number decreases. Okay, when something is reduced, the oxidation number decreases. And just as an example of that, right, when an atom or ion is reduced, we're talking about the grr side of things. So this is gaining electrons. So if we want to think of this as F2, right, plus 2 electrons, giving you 2 fluoride ions, you've gained electrons and your oxidation number is going to go down. Well, how do we know that? Right here, the fluorine, elemental fluorine, has an oxidation number of 0. And over here, the fluorine has an oxidation number of -1. It has decreased. Okay, it has decreased. It went from 0 to -1. So the fluorine, originally 0, now -1. And then on the opposite side of things, okay, the Leo side of things, when an atom or ion is oxidized, the oxidation number increases. So let's say you have calcium metal. Okay, if it's oxidizing, it's losing electron. Well, gaining is reduction, losing is oxidation. So down below here, the calcium is going to lose electrons. How many is it going to lose? Well, it's in family 2A, so it's going to lose 2 electrons. Okay, because it forms a +2 ion. Well, in this instance, again, elemental forms of things always have an oxidation number of 0. And over here, the oxidation number of the calcium ion is +2. Here it's gone from 0 to +2, so it is, right, the oxidation number is going up from 0 to 2. Okay, oxidizing and reducing agents. This is actually how chemicals get labeled. So we're using the same reaction that we just saw on the previous slide. You could say this is potassium is oxidized by chlorine. It might be how you term that reaction. Well, the way that chemicals come labeled, they don't say this will reduce things or this will oxidize things. They say that they are an oxidizing agent or a reducing agent. Okay, an oxidizing agent is a substance that oxidizes another substance by accepting its electrons. Now this is going to be don't let this confuse you. The oxidizing agent is actually the species that gets reduced. So the thing that oxidation number is going down, that is the oxidizing agent. And why is that? Because it's accepting its electrons. It's taking its electrons, right? It's getting reduced. It's gaining electrons. So don't let that confuse you, okay? And on the opposite side of things, the reducing agent is a substance that reduces another substance by losing electrons. This is the species that loses, getting ahead of myself here, that gets oxidized. So in this reaction up here, potassium went from 0 to +1. It is oxidized, okay, in this reaction. It's also called the reducing agent, okay. So its oxidation number went up, it went from 0 to +1, so potassium is considered a reducing agent here. The chlorine, Cl2, is oxidized, no, that should say, that's funny, typo. The chlorine in this reaction is reduced. Go ahead and fix that. Is reduced in this reaction, okay, it is the oxidizing agent. All right, so its oxidation number went from 0 to -1. It went down, okay, so it is being reduced, and it is called the oxidizing agent. We're going to do some examples of these, so don't panic, and we'll probably try a few of them off of your homework. Okay, so here's a big reaction, and actually all this really is the ion form of what happens in the thermite reaction. Okay, so let's take a look at everything going on here. You have elemental aluminum, which would have a charge or an oxidation number of 0. You got an iron 3 ion, so +3. You got an oxide ion. You got elemental iron, so that would be a 0 on the iron there, a +3 on the aluminum here, and the oxide stayed -2. Okay, which substance is being reduced? Remember Leo and Gur. Okay, so which one is gaining electrons? Now you got to remember, if it's gaining electrons, its charge is going down. Its charge is going down. Well, aluminum went from 0 here to +3. Iron went from +3 to 0. Oxide was -2 and stayed at -2, so that's not a part of this, right? Oxides are not going to be a factor here. Which one's being reduced? Which one's number went down? Well, iron went from +3 to 0. So the species being reduced, the substance being reduced, is the iron 3 ion. This guy right here is what's going to be reduced. Which one's being oxidized? Well, the one whose number is going up. Aluminum went from 0 to +3. Okay, and so in that reaction, the aluminum is the substance being oxidized. And really this isn't thermite because this would be the iron 2 ion, but that's not the point here. So we have this iron 3 ion is the one being reduced, going from +3 to 0. The aluminum's going from 0 to +3. Identify the oxidizing agent and the reducing agent. Well, the oxidizing agent is the thing being reduced. So that is just going to be the iron 3 ion. And the reducing agent is the thing being oxidized, aluminum. And there you have it, okay? And the reason that you're learning this method as well is because that's how chemicals are labeled. They're not labeled like this. They're saying something is an oxidizing agent or a reducing agent on its label. Okay, so how to determine oxidation numbers. You got a big old set of rules there on the right-hand side. The oxidation number of an atom, of an uncombined element, is 0. So anything that's just a pure element, the oxidation number is 0. If it's got a charge on it and it's a monatomic ion, so a single element that's turned into an ion, it's simply just the charge of that particular thing. If you've got so here we got the oxidation number of a more electronegative atom. We haven't talked about that. That's okay. In a molecule or a complex ion is the same as the charge it would have if it were an ion. And we'll do an example of these in a moment here. The oxidation number of most electronegative element, fluorine, is always -1. So fluorine, no matter what in compounds, is always -1. Can't be anything but that. The oxidation number of oxygen in compounds is virtually always -2. The only exceptions to that is if you have something like a peroxide, which honestly I'm probably not going to give you, or if you have a metal hydride, which once again, that's actually down below here. You're not going to see that with what I'm going to show you, okay? Or if it's bonded to fluorine, but we're not going to see that in this case. The oxidation number of hydrogen in most of its compounds is +1. Unless you're bonded to a metal hydride. So that's what I was just talking about here. So if it's by itself, hydrogen is usually on the +1 side of things. It's usually +1 as its oxidation number. Now it looks like I wrote 2 H's, so we go and do that. Okay, usually has an oxidation number of +1. Unless it's a metal hydride, I'm not going to give you these, then it would be -1. The oxidation number of groups 1 and 2 metals and aluminum are positive and equal to their number of valence electrons. Okay, so that's just what family is it in, what kind of an ion would it form. That's what the oxidation number would be. Okay, the sum of the oxidation numbers in a neutral compound is 0, and the sum of the oxidation numbers in a polyatomic ion is equal to the charge on that particular ion. We're going to do examples of these, so don't panic. But having that chart will be handy for you. What is the oxidation state of potassium in KClO3? So rule 7 tells you that potassium is a 1A metal, so the charge in the compound must be, it's family 1A, it's got to be +1. So its oxidation number is going to be +1. Oxygen, we said, is always -2 in compounds unless it is a peroxide or bonded to fluorine, not what we've got here. So to figure out what the oxidation state, we should do this of chlorine, not of potassium, so I'm going to go ahead and cross that out up here. Of chlorine in this compound. Well, the whole thing has to add up to 0, right? We have to have a whole thing of 0 because it's a neutral compound. Each oxygen is -2, so you've got a total of -6. Okay, we'll say that the chlorine's oxidation number is X and the potassium is +1. Okay. We simplify this down. You've got X minus 5 equals 0. So X is equal to +5. So the chlorine in the chlorate ion, potassium chlorate, has a +5 charge to it. Okay, so we set that up here. The oxygen, each is -2, so that gives you -6. The chlorine we didn't know, so we said that was X. Potassium in compounds is +1. We set it equal to 0. If it had a charge up here, we would put that down here. And then we just solve for whichever element we need to solve for. All right, and we'll do some more of those, so don't panic. I'm going to do a couple of the ones off of your homework sheets. And then we got a double replacement reaction. We've got KBr plus Cl2 giving potassium chloride and a liquid bromine. It wants you to identify the oxidizing and reducing agents. First, you need to get the net ionic equation here. So what's going on? Well, you've got potassium ions plus bromide ions plus chlorine, elemental chlorine, giving us potassium ions plus chloride ions plus elemental bromine. Okay? That's what we are working with. Well, in this reaction, let's just take a look here. Potassium's oxidation number in this one is simply just its charge, so it is +1, and it's +1 over here. Bromine is -1 here based on its charge. It's a monatomic ion, so its charge is just equal to its oxidation number. Chlorine here is an oxidation number of 0. It's elemental. That's what its elemental form is. Over here, the chloride ion is -1, and the bromine is now elemental, so it is now 0. Okay, so let's do this in terms of Leo and Ger. Okay, the substance losing electrons, the one losing electrons, its oxidation number is actually going to go up. Okay, which ones went up? Well, bromide ion went from -1 to 0 over here. It actually went up. It went from -1 to 0. So the substance that is losing electrons, that's getting oxidized, is the bromide ion. The substance that's gaining electrons, well, Potassium stayed the same. It went from +1 to +1, so it didn't participate in this redox. And then you got chlorine going from 0 to -1. It has gone down. It's gained electrons, so it's gaining negative charge, so its oxidation number is going to go down. So the species that's getting reduced is the chlorine. Well, now you can identify which one is which in terms of the oxidizing and reducing agents. The one that is getting oxidized here, this is your reducing agent. And this one here, Cl2, that is your oxidizing agent. And that's how you would identify that. So you have to figure out what are the oxidation numbers of all the species involved in the reaction in order to then figure out which one's oxidizing agent, which one's reducing agent. Okay, and then for good measure, let's take a look at one problem from your homework. So this is worksheet 5.4 with the oxidation numbers. The first one at the top is HNO3, and it wants to know what is the oxidation number of the nitrogen. Well, knowing what you know about this, it's got a net of 0, so we have to have that equal 0. Each oxygen is -2. You've got 3 of them for a total of -6. We don't know the nitrogen, we'll call that X. And the hydrogen, one of the rules tells you that all hydrogens, unless it's a metal hydride, is +1. So you've got X minus 5 equals 0, X equals +5. So the answer for that one is +5. Okay. And then let's take a look very quickly at the one down beneath, down there with number 15. It says identify the species oxidized and the species reduced in each of these redox reactions. Well, you've got, I'm not going to write out all the numbers here, you've got elemental bromine plus elemental gallium. Actually, we'll just put in the numbers for good measure. Giving you 2 gallium bromide. This is elemental bromine. It's got an oxidation number of 0. Elemental gallium by itself, oxidation number of 0. Now it's in a compound. All right, bromides in compounds are each -1, and gallium in this compound has to be an oxidation number of +3 because it's bonded to 3 bromides. Well, which one is losing electrons? Which one, okay, which oxidation number went down? Well, the bromine went from 0 to, actually, bromine went from 0 to -1, so its oxidation number went down. But if it's losing electrons, like the gallium is here, its oxidation number is going to go up. So the species that is getting oxidized is gallium, this guy right here. Its oxidation number went up. If you're gaining electrons, your oxidation number is going down. Bromine went from 0 to -1 over here. So the elemental bromine is your species getting reduced. Okay. All right.